So this video is on assignment number 3 in Unit 1, solving one-step equations. So let's go to and just talk about what that means. To solve an equation means that you find the number for the variable that makes the equation true. So we want to find the number in the variable that makes the equation a true equation. Let's just take a look at some examples here. We have 3 examples here, A, B, and C. And the first example says we start with a number that when we subtract 4, so we have this number, and when we subtract 4, we get the number 13. So we want to know what is that number that we subtract 4 from to get 13. And so a lot of times we talk about the inverse of a number. The inverse of anything is doing the opposite of that thing. For example, the opposite or the inverse of putting your shoes and socks on is taking your shoes and socks off. The inverse of subtracting 4 is adding 4. So what we're going to do first here is add 4. And we're going to add 4 to both sides of the equation. Because whatever I do here, I want to make sure I do here to make sure that that equation remains equal. So here I have, on the left-hand side, I have n minus 4 plus 4. But minus 4 plus 4 is 0. So it's n plus 0, which is just n. And then when I add 4 to the other side, 13 plus 4, I get 17. So we can check this by sticking 17 back in for the variable to make sure that it is actually true. If I stick 17 in for n, does 17 minus 4 equal 13? And we see that it does, and so we have the solution, n equals 17. For equation B, 5 times x, remember that when a number is next to a variable, that means to multiply. So we want to undo that so that we can get the x by itself. So the opposite of multiplying by 5 is dividing by 5. So I'm going to divide this side by 5 and this side by 5. When I multiply by 5 and divide by 5, that gives me just 1. And 1 times x is just x. But because I want to do the same thing to the other side of the equation, 35 divided by 5 is 7. And so let's check that. Let's plug 7 back in for the x and make sure that it does equal 35. Does 5 times 7 equal 35? And we know that it does. And so we have an equation, that we have a solution to that equation. Let's take a look at part C. We're starting with a variable, some number that when we divide by 3, the result is 12. Well, what's the opposite of dividing by 3? Well, the opposite or the inverse of dividing by 3 is multiplying by 3. So I'm going to multiply this side by 3 and the right side by 3. And when we divide by 3 and then multiply by 3, those undo each other. They're inverses of each other. So we're just left with W. And this side, 12 times 3 is 36. And so we know that W is 36. Let's just check that out mentally. If I plug 36 in for W, does 36 divided by 3 equal 12? And we know that it does. And so our 3 solutions are n equals 17, x equals 7, and w is equal to 36. Let's try some more here. And these are a little bit more difficult because we have some positive and negative numbers that we're working with. We have a fraction that we're working with. But if you thought these problems were easy, these problems are just as difficult. Or just as easy, but we're going to have to know our operations with integers and with fractions. So let's see if we can do A first. Again, just like before, I want to undo adding 5. So the inverse of adding 5 is subtracting 5. So I'm going to subtract 5 from this side and subtract 5 from this side. Over here, I just have n. But then n equals negative 11 minus 5. So negative 11 minus 5 is the same thing as negative 11 plus a negative 5. We change the negative or the subtraction sign to a positive sign and then make it that we're adding the opposite. So it's like we have 11 bad guys plus 5 more bad guys, that's a total of 16 bad guys. So n is negative 16. Let's check this out and make sure that it actually works. If I plug negative 16 in here, does negative 16 plus 5 equal negative 11? So we can think of this as 16 bad guys plus 5 good guys. So the 5 good guys can wipe out 5 of the bad guys, and we'd have 11 bad guys left. And so it does equal negative 11. So our solution is n equals negative 16. For part B, we're multiplying by negative 3. So we're going to divide by negative 3 because those are inverses of each other. And so if we divide by negative 3 and multiply by negative 3, those undo each other. And then on the right-hand side, 15 divided by negative 3 is negative 5. And if I just plug this in, I could probably do this mentally. Does negative 3 times negative 5 equal positive 15? We know that a negative times a negative does equal a positive, and 3 times 5 is 15. And so x does equal negative 5. Now, there are several ways to think about part C. I'm going to do this by multiplying by the reciprocal. I want this to be 1w. And if I take 3/4 and multiply it by 4/3, then what will happen is this. The 3's will cancel out and the 4's will cancel out. And the only thing that I'll be left with is w. But just like all the other problems that we've done so far, when we do something to the left of the equation, we have to also do it to the right of the equation. So on the left-hand side, we multiplied by 4/3. And on the right-hand side, we're going to multiply by 4/3. So there's several ways to think about this. I like to do it by multiplying by the top and dividing by the bottom. So I'm going to take 12 times 4, which is 48, and 48 divided by 3 is 16. So w equals 16. And I could take 3/4 times 16 and make sure that I get 12. Again, I would take 16 times 3 and divide it by 4. 16 times 3 is 48. 48 divided by 4 is 12. And so w equals 16 is my solution. So there we have the 3 solutions. Let's take a look at these 2 examples. Now these 2 examples, what we're doing here is we're going to have to write an equation and then solve it. So this is a little bit more involved than the last 2 slides. The cost of a Gatorade is $2.50 per bottle. John spent $17.50 on Gatorade. Maybe he was buying it for him and some of his friends. So how many did he buy? So what I'm going to do is let my variable be a B for the Gatorade, the bottles of Gatorade that he bought. And it was $2.50 for each one. So if he bought 1 bottle, it was $2.50 times 1. If he bought two bottles, it's $2.50 times 2, or $2.50 times 3. We don't know how many he bought, but we do know that his total cost was $17.50. So there's our equation. So how do we solve that equation? Well, we're multiplying the number of bottles by $2.50, so I'm going to divide by $2.50. And I'm going to take $17.50 and divide it by $2.50. On the left-hand side, those are inverses of each other. They cancel each other out, so we just have the B. On the right-hand side, if I take $17.50 and divide it by $2.50, we can do this with the calculator. You can do it in your head. But $2.50 goes into $17.50 7 times. And we could check this out. If we take 2.5 times 7, we should get $7.50. So how many did he buy? He bought 7 bottles of Gatorade. And that would be our solution. Let's take a look at part B. Susan bought a hot dog with a $5 bill and had $2.75 left. How much was the hot dog? Well, I'm going to let H be the hot dog. She started in her pocket with $5, and she bought the hot dog, which means she subtracted the amount of the hot dog. 5 minus the amount of the hot dog is what she has left, which is $2.75. So with this one, it's a little bit, it's really a two-step equation, and we've been working with one-step equations because what we're going to have to do is subtract 5 from both sides first. So we still have a negative h, and $2.75 minus 5 is negative $2.25. So a negative h is negative 225. What do you think a positive h is going to be? Well, a positive h is going to be a positive 225. And we're going to talk more about this in the upcoming days, but you could think of it like this. This is like negative 1 times h. So if you divide this side by negative 1 and the right side by negative 1, both would end up being positive. And a hot dog must be $2.25. And we could check this out by sticking the $2.25 back in for h. Does 5 minus 225 equal 275? And we know that it does. And so a hot dog is $2.25 for a hot dog. All right, there you have it. That's the notes for assignment number 3. And we will talk more about this tomorrow in class.